Welcome to today's video on section 2.6, graphing rational functions. I have this process outlined for you to follow. First, you want to determine the symmetry, whether it has y-axis symmetry, which means it's an even function, or if it has origin symmetry, which means it's an odd function. And going back to chapter 1, when it's an even function, remember it's symmetric to the y-axis, and when it's odd, it's symmetric to the origin. You substitute in negative x. If it's the same when you substitute it in, and here notice when I substitute in it's not the same, therefore it's not symmetric to the y-axis or even. When I take out a negative and see if when I put in a negative x, I get the opposite out. If it's symmetric to the origin, notice it is not, because I don't get the same thing when I take out the negative. Therefore, this does not have any symmetry, so it's neither. Finding the y-intercept by putting 0 in for x. So I get negative 1 over negative 1, which is 1. So the y-intercept is 0, 1. So then I find the x-intercept by just setting the top equal to 0. So 2x minus 1 is equal to 0. So 2x equals 1, x equals positive 1/2. So 1/2 comma 0 is the x-intercept. Find the vertical asymptotes by setting the denominator equal to 0. So the denominator is x minus 1. So the vertical asymptote is x equals 1. The horizontal asymptote, well, since the degree of the top and the bottom are the same, I take the leading coefficients and I divide them, so 2 over 1 is 2. So the horizontal asymptote is y equals 2. And then I'm going to plot one point between and beyond each x-intercept and vertical asymptote. So let's use the information here. I know that the y-intercept is at 0, 1, so I'll plot that right here. I know the vertical asymptote is x equals 1. I know the horizontal asymptote is y equals 2. And I know that the x-intercept is 1/2, so it's right there. So now what I need to do is plot a point, as it says, beyond and between each x-intercept and vertical asymptote. So I want to plot a point in this direction of the y-intercept, and I want to plot a point in this direction of the vertical asymptote. So to the left of the y-intercept, I'll choose negative 1. So remember, the function was f of x equals 2x minus 1 over x minus 1. So I'm going to put negative 1 in. So 2 times negative 1 minus 1, negative 2 minus 1 gives me negative 3. And then when I put negative 1 into the bottom here, negative 1 minus 1 gives me negative 2. So it's 3/2, or 1 and 1/2. So it's about right there. So notice right here, it's going to look something like that. Because remember, the graphs will follow the asymptotes, but they won't touch the asymptotes. So that part of the graph looks like that. So now on this side of the vertical asymptote, I pick a point, and I'm going to choose 2, because 2 is the next point to the right of x equals 1. So 2 times 2 minus 1, and 2 minus 1. So 2 times 2 is 4, minus 1 is 3. 2 minus 1 is 1. So when I put 2 in, I get 3 out, which is right there. So basically, as I saw before, when I have a point here, I know that the asymptote is going to follow the asymptotes like that. And there you go. So there's my graph of 2x minus 1 over x minus 1. So let's try again. So the first thing here, we're going to Actually, let's go to the next one. Let's skip one. Let's do 3x squared over x squared minus 4. So the first thing, remember, is to determine symmetry. Well, in this case, if you put in a negative x and square it, whoops, negative x and square it, it gives you a positive x. And when I put in a negative x here and square it, it gives me a positive x. So notice, when I put in the negative x, I get the same thing, so it's symmetric to the y-axis. 2, find the y-intercept. So I put 0 in for x. So I get 0 over negative 4, which is 0. So my y-intercept is 0, 0. My x-intercept, I solve the top equal to 0. Well, 3x squared equals 0. So when I divide by 3, I get x squared equals 0 and x equals 0. So the x-intercept is also 0, 0. So here's the x-intercept and the y-intercept. Now the vertical asymptote, remember the denominator is equal to 0, so x squared minus 4 equals 0. When I factor this, I get x minus 2 and x plus 2. So that gives me x equals 2 and negative 2. Those are my vertical asymptotes. So here's a vertical asymptote at 2, and here's a vertical asymptote at negative 2. The horizontal asymptote, since the degree of the top and the bottom are the same, I'm going to take the leading coefficients, which are 3 and 1, and divide them. So y equals 3 is the horizontal asymptote, which is right there. Now, to plot some additional points, now notice, I'll plot one point to the right here, which is 1. When I put 1 in, notice I get 3 over negative 3, which is negative 1. Now, since it's symmetric to the y-axis, that means if I put negative 1 in, I'm going to get the same thing. So I'm going to have, in the middle here, I'm going to have a parabola. Now notice, to the right, I'll put in a point. I'll put negative 3 in. Or sorry, positive 3. So 3 squared times 3, and then 3 squared minus 4. 3 squared is 9, times 3 is 27. 3 squared is 9, minus 4 is 5. So 27/5 is the same as 5 2/5, which is about right there. Now, since it's symmetric to the y-axis, at negative 3, it's also going to be 27/5, which is right there. So I'll just do one more point, just so you get the idea. I'll put 4 in. Well, 4 squared is 16 times 3 is 64. Or sorry, 48. And 4 squared is 16 minus 4 is 12. So when you divide, you get 4. So when you put 4 in, you get 4 out, which is right there. And it'll be the same over here on the negative side. So you notice it's going to look something like this on either side. And notice it's symmetric to the y-axis. So that is your graph there. All right, let's try the next one. X to the 4th over x squared. Well, notice if we do symmetry, Actually, why don't you try this one on your own, and then I'll come back and show you. Hi. Now, if you look at this one, doing some of the work here, the symmetry, it's the y-axis symmetry, because you get the same thing when you put the negative x out or in. Y-intercept, you get 0. X-intercept, you also get 0. So that's them. Vertical asymptotes, there's no number that you can put in here that would give you a -1, so that's none. And then horizontal asymptote, remember when the degree of the top is bigger than degree of the bottom, there is none as well. So you don't have any asymptotes. So now let's put in some numbers like 1. Well, 1 to the 4th over 1 plus 1, that'd be 1/2. And since it's symmetric to the y-axis, -1 would also be at 1/2. So then when we put in a 2, 2 to the 4th over 2 plus 1, so that'd be 16 over 3. So that'd be 5 1/3. So 1, 2, 3, 4, 5 1/3, and it'd also be the same on the other side. So notice, because it's an even function, that it's just going to be a parabola like that, and there are no horizontal or vertical asymptotes. Now, a function that does not have a horizontal asymptote may have what's called a slant asymptote. If the degree of the numerator is only 1 more than the degree of the denominator, you have a slant asymptote. To figure out a slant asymptote, you basically divide the denominator into the numerator. So here, if you have x minus 2 and 2x squared minus 5x plus 7, notice degree of the top is 1 more than the bottom. You can do synthetic division, and basically you bring down the 2. 2 times 2 is 4, -1 times 2 is -2. You get a remainder of 5. Now, the part here, the 2x minus 1, which is left over, this is your slant asymptote. You just ignore the remainder. So your slant asymptote for this function would be 2x minus 1. All right, this concludes our video for this evening. We'll go over this in class tomorrow, and I hope you guys have a good holiday if I don't see you.